the the way this is presented to us, that's not the most useful or appropriate format to gain our transformations. Okay, I kind of compare it to, like, we had standard form and vertex form for parabolas. From one of those forms, you gain a lot. In the other form, you don't. Okay, I think in this format, you don't gain a whole lot. Okay, and it's because of this coefficient right there. Okay, when that thing is a 1, we can visually look at our equation and make some conclusions. But when it's not a 1, we can't do that right away. Okay, so what I'm going to do is I'm going to try to make that a 1. So the way we make that a 1 is simply through division. Okay, factor it out. I'll factor it out, and when I factor 2x out of, or 2 out of 2x, it leaves me with x. And when I factor out a 2 out of 2 pi over 3, factoring out is the same thing as dividing, right? Dividing by an integer is the same thing as multiplying by its reciprocal, right? So if I take 2 pi over 3 and multiply it by a half, doesn't that just give me pi over 3? Does that make sense? Okay. And something, I didn't mention this yesterday, but something that I think is always useful, once you've factored that b value out, quickly distribute again and make sure that you get back, when you distribute to that last part there, that you get back to 2 pi over 3. That tells you that you got an alternative form of what you started with, right? So now identifying these things, okay, this is my vertical shift, or sorry, my vertical stretch, okay? And because it's between 0 and 1, it's actually a shrink, okay? That's the amplitude, take the absolute value of it. That value there, the factor that we pulled out, is our b value. And what does b impact? Period. So the period is 2 pi over 2 in this case, so pi. And then the pi over 3 is our phase shift. And which direction is that going to move? Left. Okay. Now, here's what stinks about this. If I go ahead and I start establishing my x-axis, so if that is pi, cut it in half, pi over 2, get that in half, pi over 4, 3 pi over 4, okay? And I put a point, so cosine, there's going to be a point, if the normal cosine would be at 0, 1, right? But when I multiply by 3/4, there's going to be a point here eventually right there. And that point is going to need to be moved pi over 3 units. Is it going to be hard to judge because of how my x-axis is established right now, how far to move that? Okay, so this is what I do, okay? It's just doing a little, you got to do a little bit of legwork at the beginning to make things easier for yourselves later on. I look at the smallest unit that I have established on my x-axis, and it's pi over 4. And I look at my phase shift, and it's pi over 3. Okay? So I know I'm going to have points that are at pi over 4, pi over 2, 3 pi over 4, and pi that need to move a pi over 3. The only way that that's going to be easy for me to do is if I compare these, pi over 4 and pi over 3, what would be a common denominator for those things? Pi over 12. So that tells me right now that I'm going to establish my x-axis in terms of 12ths. And that will make it easy for me to decide how to move certain objects. So, in terms of 12ths, this would be 12 pi over 12. This would be 6 pi over 12. Okay, and this would be 3 pi over 12, right? So that means, if that's 3 pi over 12, that means that this would have to be broken up into thirds, and that would be pi over 12 and 2 pi over 12, right? Break this one up into thirds. Break this one up into thirds. Trying to do the best I can at keeping things consistent. And we're also going to have to go over here a little bit. So I'll try to capture that so that is maybe pi over 12. See if I can do it again. 2 pi over 12. 3 pi over 12. I need one more. I need to go to 4 pi over 12 over here. And the reason, so this is, like I said, this is negative pi over 12, negative 2 pi over 12, or negative pi over 6, negative 3 pi over 12, or negative pi over 4. And this would be negative 4 pi over 12, which is negative pi over 3. And the reason I knew I had to go out to 4 pi over 12 over here is because aren't we moving it pi over 3 units to the left? So this point right here, which is located on the y-axis, needs to be moved a complete pi over 3 units that direction. Does that make sense? Okay. That, in my opinion, that's the hardest thing. Okay. That is what I find students struggle with the most in regards to graphing these things, is establishing the x-axis correctly and moving our points in a manner that allows us to move our points in a scaled manner, okay, so that every point is moved the same amount, okay? So now, what I want to do is I want to take my cosine function, okay? So I'm just thinking right now about my parent function, and our parent function for the cosine starts at 1, finishes at 1, halfway in between, negative 1, right? Okay, so that's our generic parent function for the cosine, which you just hopefully demonstrated to me on the quiz. What's the 3/4 going to do to all those ordered pairs that have a y value of 1 or negative 1? Yeah, it's going to make them go to 3/4. So I'm going to do that vertical compression along with obviously the period we've already taken care of, but I'm going to do that vertical compression right now on all of these points. So 0, 1 is going to go to 0, 3/4, okay? Then at the end, so when I get all the way through to the end of my period, which in this case is going to be pi, shouldn't that be at the same height? And then at negative 1, that's going to go to negative 3/4, and that's an x value of pi over 2. Okay. Now, this one here and that one there correspond to that point right there, that x-intercept, and that x-intercept on the parent function, right? So right now, think about what those blue points on our graph are. And I'm not going to, you could connect those if you want to. I think that makes the final graph messy, okay? What we have, though, right now is that we did the 3/4. We applied that, okay? We know we're dealing with the cosine, okay? We shortened our period to pi, so we dealt with that too, okay? And the only thing now left is this x plus pi over 3 that we haven't dealt with, right? So these 5 points are pretty much everything we need except for the horizontal movement. So now every point needs to be moved pi over 3 units. Well, if I look, and this is why it's been nice for us to set up our x-axis this way. If I look at these points, okay, that needs to be moved to pi over 3 directions to the left, so negative pi over 3. Well, how many tick marks is that? 4. So if I move that one 4 units to the left, 4 tick marks, how far do I have to move this one? I move this one 4. Okay? And that is what that initial, so I'm going to, let's do it this way. I can't grab those because it's going to grab a lot of other things when I highlight it. So let's just use this color. So we'll take that one, move it 4 units to the left. Okay? Then we'll take this one, 1, 2, 3, 4 units to the left. Take this one, 1, 2, 3, 4 units to the left. Take this one, move it 1, 2, 3, 4 units to the left, and then this one 1, 2, 3, 4 units to the left. And by doing that, okay, we saved ourselves so much time in altering the coordinates for the purple curve. Does that make sense? So it's a little bit more legwork at the beginning, a little bit more in terms of developing our x-axis. But if you were to compare it to an alternative approach, it is so much faster, so much more efficient, and a lot less stressful than what it could be. Okay, so take that time to establish your x-axis correctly. So then it's just a matter of counting each one of these over 4 units. Okay, once you have that, then obviously, just like any other sine or cosine curve, we're still looking for that smooth, gradual curve. Is that all right? If we needed to, we could go back and negative pi over 3. This point would be then at positive 3/4 for the y value. This would be negative pi over 12, comma 0. Pi over 6, comma negative 3/4. Okay, so this would be 5 pi over 12, comma 0, and this one would be, so this would be what, 9 pi over 12. So this would be 8 pi over 12, or 4 pi over 3. Is that right? 9 pi over 12. So this is 8 pi over 12. No, sorry, it's 2 pi over 3. 2 pi over 3, comma, positive 3/4. If you needed the ordered pairs for whatever reason. I like to put those ordered pairs because what I always do then, because there's so many places that you can run into a problem here, right? Okay. And now I don't know what Desmos is going to do here. So let's just see if I go 3/4 cosine of 2x plus 2 pi over 3. Now, Desmos will always give you these points, okay? So let's see, negative pi over 3, 3/4, negative pi over 12, 0. All right, so y-intercept, pi over 6, negative 3/4. These are the exact same points that we listed, right? Okay, so that's a nice thing about Desmos, but also the reason why maybe on some handwritten tests and quizzes I don't let you use Desmos, because you could just type that in, get the information, plot it down, and have absolutely no idea where that information came from, right? But again, like I said, that is one of the more complex types of problems that we would see. We will also see maybe down the road, not so much right now, but maybe like an ACT question might ask this eventually. Let's say I had like y equals, I'll just say cosine of, let's go 2x plus 2. Okay. Normally that thing is in terms of pi, right? Now it's not. Okay. So when it's in terms of pi, that's because when we establish our x-axis, we let our x-axis be in terms of pi. But now if I do this, I have cosine of 2 be x plus 1. Okay. So this is where it gets really frustrating. Is if I were to graph this, the period is pi, right? Okay. But how far do I need to move that thing? I need to move it 1 unit to the left, right? Okay. So not only do we need now our x-axis to be established in terms of pi or irrational numbers, we want our integers also showing up there, so it makes it easy for us to move things. That's a nasty problem to have to go through in establishing that x-axis. Does that make sense? However, if I don't ask you to graph this, can I still ask you all the questions like, hey, what's the period? What's the vertical movement, horizontal movement? What's the phase shift? Which is the horizontal movement? What's the reflection? That type of thing, right? Okay? So just be on the lookout for those types of questions. I can't ask you, because of time constraints, to do, 2, 3, 4, 5 of these things, okay? Because of that time, that commitment to doing one. But I can maybe ask you to do 2 or 3 of these. We should be able to get through those relatively quick if we know what our parent function looks like. Is that right? All right. I would like to start